Welcome to RC Video Reviews. Today we're going to cover the build review of the Sebart 90mm Avanti. Now before I get into the content, I need to let you know this video is sponsored by China Hobbyline, who sent me the 8S 5070C batteries I used in this build. I'll have a link in the description if you'd like to pick up some of these batteries for yourself. Thank you, China Hobbyline, for sending these batteries out and sponsoring this build. I'd also like to thank High-Tech, who sent me the awesome D85MG servos that we used in this build. You need 7 of them. That's 2 for the ailerons, 2 for the flaps, 2 for the elevators, 1 for the rudder. And then the plane comes from the factory with a couple of other servos installed for gear and the gear door up front. Let's take a look at the hardware we used in this build. For the RF tech, we're using a Radiomaster ER8 up front, and I've got a Radiomaster ER6GV in the tail in the vertical stabilizer. We'll talk about why I did that later. That is the brake controller that comes with the electronic brakes, which we added to this plane. So this plane has electronic brakes. There's a BEC there and a BEC here on this side. Dave will explain why those are there in a little while. I mentioned the battery already. The ESC is a Hobbywing 120 amp Platinum V5, and the EDF unit and the motor are JP Hobby 90mm 8S.
I'm actually going to say why he did the receiver in the back here, to make my life miserable. That's why he did it.
No. Come on. All right, I think that pretty much covers the hardware. Is there any other hardware that I missed on this, Dave? I think we got it all.
I think so, and if not, we'll cover it here in a minute.
Yeah. All right, let's talk a little bit about the radio setup in this plane. I mentioned I used 2 receivers, an ER8 up front and an ER6GV in the back. Now, the reason I did that was just to show that it can be done and how to do it. I also did it because by using 2 different receivers, I had enough pins or nothing had to be put on a Y, which means I have individual control over every surface except the retracts and the brakes. Those are the only things you don't control individually. But all of the control surfaces, the ailerons, flaps, rudder, both elevator halves, and even the nose wheel are all individually controlled. So I can set midpoints, endpoints, and trim for every single one. That gives you an opportunity to set this plane up with a great degree of precision. If you use some kind of throw gauge to measure, you can make sure that your endpoints all have the same exact degree deflection up and down, and that you can center everything perfectly. Other options to do that, of course, are digital programmers, and we did use the digital programmer to make sure the arms were at 90 degrees as installed in the plane. So there are plenty of ways to do that. I opted to use 2 different receivers and use a lot of the controls on the radio to make sure everything was centered and set exactly the way I wanted it. So again, do you have to do it? No. I could have put an ER8 in there and put everything on a Y. I could have put ailerons on a Y, could have put elevators and flaps on Ys, and done the individual mechanical adjustments and even use the digital programmer. But the point is, there's lots of different ways to handle the problem. So I wanted to try and use 2 different receivers just to see how it would work out and to show other people how to do it. One other key point, they're both running at 100 Hertz, and the receiver in the back has its telemetry turned off. The receiver in the front has its telemetry turned on, and that's where I get things like my battery voltage and my signal quality.
A nice little feature that ended up happening as a byproduct was we got individual trim control of the rudder and the nose gear.
Yeah. Everything individually controlled. Yeah. So if you're flying and your rudder trim isn't where you want, you can trim it and it won't affect how the plane lands and steers on the ground.
Exactly.
It's very cool.
Yeah. That worked out.
Now, on the radio, I did some very special things. It is definitely my most advanced configuration I've ever put on an Edge TX radio. Let me walk you through a couple of the tricks that I put together on this setup. First off, the brake circuit is activated only when the gear are down and the power is reduced to 0. Then you can utilize the brakes. If the power is activated, the brakes are disabled. And if the gear are up in the wheel wells, the brakes are disabled. The next feature on the brakes is that they are activated with the elevator. So as I push the elevator stick forward, it activates the brakes, and when I hit 100%, it activates an anti-lock braking circuit. That's right, I configured anti-lock brakes using Edge TX on this radio.
Writing code
on the radio. And it works fantastic. We did a lot of back and forth testing on the runway today, and it works really, really well.
And just to clarify something, is not a mechanical speed sensing anti-lock brake, is a time base, like a timer.
Yeah, the analog brake pulses on and off based on a time configuration, and the activation of the analog brakes has to do with how much pressure you put on the stick.
Which that time is also settable to
Yes.
increase it or decrease the
That's
pulse.
right. The time is settable. You can adjust it. I also set up all the mixes that Sebart recommends for this plane. There is a rudder to elevator mix, so if you have full deflection on the rudder, they want 4% down on the elevator. Per the book, I also have a mix set on the rudder to ailerons, and the idea there is you have an opposite mix. So if you have left rudder, you give right aileron. If you give right rudder, you give left aileron.
And that just keeps it from rolling out of the knife edge when you're doing it, which is, you know.
We also have differential ailerons, which helps with adverse yaw. That's configured in this one. And finally, there is a flap to elevator mix. So when I deploy those flaps, we get a little bit of down elevator. And again, that's per the book.
And the differential on the ailerons is the aileron, the surface going up, goes a little further than the one going down.
That's right. That's exactly right.
Differential.
Now, regarding this radio configuration, I opted not to go through all the details in a video because frankly, unless you're very interested in this, that'd be pretty boring for you. What I'll do instead is post this radio configuration file in the Jets and EDF channel of my Discord. So if you'd like to take a look at this configuration file and all the associated logic that I created for this one, it'll be on the Discord in the Jets and EDF channel. There's a link to my Discord in every single video I post. So if you'd like to join us on Discord, feel free to click that link. Next up, Dave is going to talk about the build process and what he encountered assembling this plane. He did all the work here. Dave assembled the whole thing. I simply supplied the parts. Dave, let's walk him through it.
Okay, first of all, I've had Sebart airplanes for a long time. Long before I met you, and I love them. The airplane is absolutely gorgeous. The finish of the paint, the fiberglass is gorgeous. I do want to say, when you buy the plane, be careful, just check that your control surfaces are lined up, and stuff like that, because sometimes they're not. So do a dry fit of all your control surfaces before you put them in, because sometimes the hinges are not exactly in the center, so you want to check that. There's few things, but with the construction of the plane, but that doesn't matter, because at the end of the day, look at the airplane. You cannot build something like this. You can't. So just deal with tiny little things here and there for the money. Okay, gorgeous plane. If you're gonna build them, not only these, any airplane, dry fit everything, look at everything, and if you run into little details, just fix them, because it's a lot cheaper than trying to build something like this yourself from scratch. So there you go. We had a little some with the stabilizer, just dumb stuff, but it's all fixed, all taken care of. Okay, so the build. The plane, they claim, Sebart, that the build takes about 12 hours. Okay? Yeah, but wait a minute. They don't know what we did with this thing. So if we didn't do this and we build it the way they intend it to be built, I take longer. Let's say I would have taken 24 hours. A fast person probably can do it in 12 hours, maybe. But then they are not looking at all these minor details that we were incorrecting. You know what I'm saying?
Yeah.
Okay. So first of all, we have a lot more systems and circuits on this airplane that are called for or needed. Here's one receiver, which is the main receiver. We don't call it main because they're both main. This is receiver number 1, takes care of everything that's up here on the airplane. Receiver number 2 is up here inside the rudder through this. Can you show this compartment here? When we remove the servo from the tail, when we remove it, take it out, the receiver is up there inside the rudder, the second receiver. John already explained why we did that. And I explained it better to make my life miserable. But anyway, there you go. It was challenging to get this here the way it is, because the servos are just a hair bigger than they recommended. We had, they fit very good everywhere, but this is tight. So it took some time. It took some time to do that. We got that taken care of. That's good. Okay, so as far as the equipment on the airplane, why did it take so long? We're using dual receivers, one here, one back there, to have enough channels. We are using brakes. We are using dual power supplies. We are using triple, because one of them is dedicated for the brakes only.
And why do we have to use a standalone back for the brakes?
Okay, our servos are rated for 6 volts, right?
Right.
And So we're running the whole system, and actually I believe the original airplane, the systems were 6 volts. I don't know if they upgraded them or not. But anyway, so we needed 6 volts for the flight control systems for the airplane, but then the brakes wanted to operate at a minimum of 7.4, I believe.
7.4, that's the
So
number.
we chose a higher, the higher we can go. I think we could have gone to, what was it?
It was something higher, like 10, but
10.
we went with 8.4.
8.4, which is the higher that we can get out of the BEC external.
Right.
And that is why we have a BEC exclusively and dedicated for the brakes.
Right.
Which I like that. We don't want to lose. We're running dual power supplies here. It's redundant power systems feeding our control systems. One of them is coming from the ESC, which is the regular BEC out of the ESC. The other one is the 15 amp BEC, external BEC, okay? Now, be careful. We are running them through diodes. They are...
Shocky.
Yeah, they're the Schottky diodes, which the silicone diodes have a 0.7 volt voltage drop. These have between 0.3 and 0.4 voltage drop. And the reason why we're running the diodes because we don't want to feed power back either from the ESC into the BECs or from the BEC into the ESC. We don't want the power to be fed back because we don't want to burn anything. So, okay, that's our dual control system. Now
so let's be clear, Dave.
Okay.
The dual power, the two things that feed power to the circuit are the BEC, the ESC, BSC. So that's on the hobby wing. That's 6 volts.
That's 6 volts.
And then you've got a standalone BEC, also set at 6 volts.
Set at 6 volts.
And they both have diodes, right?
Yeah, they have diodes biased forward. You can pull power out, but you
can't put it in.
It doesn't allow the power to go back in. That was my design, long years ago.
So the intention there is that the higher voltage in is going to be the one that's actually supplying the current. And if one of the voltage source goes away, then the other one instantly powers the circuit. So we have redundant power into the receiver and servo circuitry.
Yes, if they're the same voltage all the time, they'll be feeding exactly at the same time. If
like
one
in parallel.
Of them goes lower, then the higher one is going to feed.
Exactly.
And or if one of them disappears, then the other one's going to continue feeding.
Exactly.
That's it.
Okay.
And that does 2 things for us. One, it provides redundancy for our power supply for our flight control system.
Right.
And it provides twice the power output that we need. You know, we got a lot of power that we can use because we're supplying 2 separate BECs to it. The ESC and the BEC.
Okay, and then the second BEC is just brakes.
Just brakes, no diode, no nothing. At the highest setting at 8.4, just for the brakes.
And we did that because we're using an 8S battery, which is too much voltage for the brake controller. So we had to use a BEC to bring the voltage down to a level acceptable for the brake controller, and we chose 8.2 volts or 8.4, whatever.
That's right. We got a diagram when I was putting all this together. So that's the thing. That's what happened. That's why it took so long. First of all, I did have to straighten out one of the ailerons and the rudder because the holes were not lined up. But remember, just look at them, fix them. I also had to work a little bit on the wing tube here in the back, which I'm going to do a little more work. It was a little on the loose side. But those are not, that for this kind of category of airplane, no worries. As per John's request, he is not interested in taking this airplane apart. So I did not put any quick disconnects for the servos and the brakes, servos, retracts, and all that stuff, and the wings. All the wires run straight up to the receiver. This airplane is not meant to be taken apart. I mean, we can separate the wings about 2 inches on each side if we need to do something. But if we want to remove them all the way, we have to pull them out from here. That's as per his request. Okay, the other thing, we ended up with so many different circuits and sub-circuits, 2 receivers, 3 separate power supplies. I had to draw diagrams, pictorial diagrams, physical diagrams, and wiring diagrams.
And I'll put those diagrams in post to give you an idea of what he's talking about.
Yeah, I drew the first one, and she'll show you that one, and then I had to draw the other ones. Yeah, anyways, yeah, that's what else can we say? There was so much to do, so long. We got all our torque stripe done everywhere, you know, that we needed it. We didn't do it on the servos because these are smaller servos. They have lock washers on them, so we didn't do that, but we'll check. We got the torque stripe on the EDF unit. Oh, and we never wind wires. It's actually better that you have them not organized or going back and forth, but don't coil them because you make an inductor. That's not a good thing.
All right, Dave, when I was looking at this plane, I had a few questions.
Okay.
One of the questions I had that was not clear to me was the thrust tube in the back. So that thrust tube, you can see it's that white tube in the back that actually comes with the plane. Talk a little bit about how you inserted that, and you mentioned that there's a little bit of there's a spar on the tail that kind of divots it a little bit.
So first, when I put it in, it took quite a bit of work to push it back enough to where the EDF unit would fit. But after the work, it fits perfect, and the EDF unit holds it, so it's not going anywhere. Now, we have a carbon tube that goes through here, out the other side for the stabilizer.
Yep.
And that carbon tube, the fuselage does not have a sleeve. You may even be able to see it from there. It does not have a sleeve, okay? So when you put that carbon tube, it kind of mashes down a little bit. And you can see the divot down here. You see the little bit of a...
Yep.
Yeah, it kind of mashes us down a little bit.
Yeah, I was focused on that, so they definitely will see it. Yep.
And actually what we're going to do later on is we're going to take these out and we are going to make a sleeve for it. We're going to make a sleeve because when we built it, there was a little bit more play here that we wanted. And that's one of those things that I'm saying, dry fit it, do put a little bit of tape on the inside, just get those, because there was a little bit more play than I like to see. So we're gonna revisit that too. We're gonna make a sleeve for it. No big deal. No big deal. We're gonna make
now, what about connecting the torque tube to the EDF in the back? Did you do anything special there?
Nothing.
Nothing.
The torque tube, pushed it back, make sure this was on the top just for the, graphics of it, for the looks, and just pull it back, push it back. And it took a lot of effort pushing it back without wrinkle in it. And once the EDF goes in, this thing is not going anywhere.
Okay.
It can't go anywhere.
Right.
Now, it could have a little bit of tape up here just to keep it from doing something, but I don't know what it would do. I don't know. We won't know until it does it.
All right.
I intended on putting the ESC under the battery tray, but it does not fit. It does not fit. So we put it as far back as we could. That's as far back as we could without interfering with the EDF unit. And we got the wires for the EDF unit zip tied down to hold them so they don't accidentally get sucked into that fan. So that's not going anywhere. We'll have another zip tie here. And obviously we'll have to do a little bit of balance, just a little bit of weight in the back because it's just a little bit nose heavy. To be determined, not on a hurricane day like today. You got to fly it like that again several times.
So we've got the heaviest elements that we can pushed as far back as we can is what we're saying.
Yep.
And we're still just a little bit nose heavy. I know some guys fly these on 10S. I don't know how they do it. 8S 70C battery. It gives the CG everything it can handle on the front end, meaning that it, as far back as we put the battery and the ESC and the motor, of course, the motor is a fixed position. Even with all that stuff pulled back as far as we can, we still were a little bit nose heavy. So that's why we have to maybe think about adding a little bit of weight in the back.
They probably relocate the ESC and move those batteries all the way back as far as they can. That's probably what and they're not this big batteries.
ESC maybe behind the EDF or something.
Or maybe on top of it back here, or they find a way to put it right in front of it, down right in between the wheel wells. That could
extend
be
all
done.
the wires.
Which we could have done that, but we don't need to do that.
Yeah.
Hi guys, I want to reiterate or emphasize on the plane is gorgeous. So when you buy like the Sebart airplanes, if you find little things, don't get all frustrated, fix them. And this is why, if you try to build this airplane and look the same way, you can't do it. You can't, the money or the time. So be a little patient with that. If you find any little thing, and just fix it or live with it, or don't worry about it if it's just aesthetic, because we cannot do this. This we can't do. So I just wanted to say that, it's just a gorgeous machine. But check them, dry fit everything, check them and fix it.
Well, you mentioned something else earlier too. You said when you're building it, you're looking at little tiny details, but when you're done and you step back and step away, then you see the entire thing, and you really have to give a lot of credit to the way this model comes together.
For instance, when I was building it, when I started doing the initial checks, I noticed the stab, the elevator was not exactly lined up with the, you'll see it on one of the pictures. It was not, but now that the airplane is put together, your eyes don't go that way. They just focus on the whole thing, and that little stupid thing disappears.
Yeah.
So there you don't not buy one because you think that one aileron is a little bit off. No, just fix it. It takes just a couple of minutes or an hour or whatever. Fix it and look at the beautiful thing you'll end up with. It's gorgeous. Wow. And that's that. You know, that's just wanted to mention that.
Good advice, Dave.
Yep, yep.
That wraps up the build video of the 90mm Avanti. I want to say thanks again, Dave. I really appreciate all the work. You can tell just by looking at the workmanship. You took your time, you did it right, and that's evidenced by the maiden. The maiden worked just fine. We didn't have any issues. I can tell you guys, Dave and I went over this plane multiple times.
Yeah, you better believe it.
Yeah, we did it at my house. We came out here to the field. We went through it again. After I was done going through it, I gave Dave the radio and walked away and said, you go through it. We really spent the time making sure this one was ready to fly. And I would encourage you on a complex build like this one that you do the same thing. Take that little bit of extra effort. And that, you know, it's kind of fun actually, making sure all the details are right. And we were rewarded with a really nice flying plane. So I'm really happy with the outcome.
Going back to the build, 12 hours, 24 is normal, but just to give you an example, just getting the receiver back here and the power, dual power fed to this receiver also. All of it
Yeah,
is
that's
dual
right.
power
We
fed.
didn't mention that. Dual power on that receiver in the back. That's
On
right.
all of it. So it doesn't matter if we lose either one of them, everything is still powered.
Yeah.
Everything is still powered. Just getting all that wire and the receiver here and the antennas and all that over here just right and the plate and this servo to fit right. It took one whole day, one entire day from 8 o'clock in the morning to about 8 o'clock at night. Because I did it, didn't like it, did it, didn't fit, did it again. It just took several times of doing it. Plus the control horns had to be modified. We had to order control horns, wait for...
To get that mechanical throw that we wanted.
To get the throw we wanted,
Yeah.
you know, and the control horns on these servos were small, so we got bigger ones, and then they were too big, so I had to fix them, redesign them.
So I just have one question, Dave. When at the end you kept sending me pictures of a beer can. I just want to know, that was always at the end of the build, right? Not during. Always at the end?
Oops. Oops. Maybe that's why
Was
it
that
took so
supposed
long.
to be at the end?
No, that was on Friday when I was done that day. Yeah, I was trying to take a picture of the planes, and then all of a sudden I see my beer can. I was like, oh yeah, this is Friday, yeah. Yeah, that was at the end. That was I was tired, done. I'm like, okay, good enough. I don't drink building these things.
All right.
You know, because you offered me a beer when we were testing everything. We said, no, let's do this freaking thing.
That's right. If you like this kind of content, make sure you smash that thumbs up button, subscribe, and hit the notification bell so you know new videos hit the channel. That's all I've got for today. Take it easy.
Hasta la vista.
And go fly something. That was a good take right there. Okay. All right, let's talk a little bit about the radio setup on this plane. I mentioned I used 2 receivers, and the main reason I did it was to show other people... What?
Just keep doing. I'm saying the main reason I did it, I already said something about it. Go ahead.
All right, if you like this kind of content, make sure you smash that thumbs up button, subscribe, and hit the notification bell so you know new All right, if you like this kind of content, make sure you subscribe, hit the notification bell. Why am I screwing this up? Can you just say blah, blah, blah for me?
Blah, 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 blah. Take 155.
Okay, all right.